In this video, we'll be planning our Dome 6 system on ballast stones or walkway slabs. This is a solution that can be done on gravel roofs, concrete roofs, and green roofs with low vegetation. It is a cost-effective solution and gives you the opportunity to raise the rails above the roof a little bit more than our standard Dome 6. What we're talking about is a product usually for green roof or a gravel roof, and you can see the cross-section of it shown here. Jumping into our base software, here we will plan a concrete roof first as a concrete roof, and then we will simulate it as a gravel roof to provide this new system and the new ballasting method. I've already planned a roof here using a project in Poland and a concrete roof. And if we jump to the summary, we see we have 360 panels, and in our results page, we can get an overview of all of our ballast. In this case, we have 4,200 kilos of extra ballast needed. To use the ballast stones under the rails, we have to go back to our building page. And what I'm going to do is copy our roof, move it up here for clarity, and just give it a new name. So let's call this one 15 kilograms, and we're going to use 15 kilogram stones on this. So we will have to now change to a gravel roof, and usually you have to put in a value of 80 or 100 millimeters and over 1,000 kilos for the density, but for this project we will just use minimum values as the gravel is not actually there. We just need to tell the software something is there, and we can then move forward with our planning. When using concrete blocks on top of the concrete or gravel material, the friction coefficient can be changed and using a value here of 1, as shown in the pop-up. Onto the design page, I still am using the Dome 6 system, and you can use some of the other systems as well if you would like to plan this style of ballasting with the S-Dome. This is also possible. Moving onto our results page, this is where the main changes occur. So I have a drop-down menu here now, and this is not present with a concrete roof or a membrane roof, but it is there for the gravel roofs. And you see the system with the concrete block options. A small warning will come up saying that we cannot calculate, and this is because we have a 0 value here, which we need to fill in. And this will be the stone that is maybe readily accessible, something you can buy easily, and you can easily get to site. So if, for the example we would like to use, we use a 15 kilogram stone, and what is going to happen is everywhere a Mat S would exist, we are replacing this Mat S with this stone, which is purchased elsewhere, and we will fix it with a specific screw. And if we go to our summary page, we can see the 2 roofs here, and the bills of material. One includes the Mat S, and if we jump to our other roof, it includes our Multi-Monti screw. You can also see the price difference here of the system. So this is 60 euros per kilowatt peak, and for our Mat S system, we have a 73. So this is obviously just as a reference, but the Mat S does cost a lot more than the screws, and you can use this as a cost-saving method if you would like to, or if you have the possibility of planning this type of system on your roof. The other thing to consider is the ballasting, and we can compare this on our results page. By clicking on this button here, we can see that the required ballast now is 180 kilos, and if we compare that to the original project where we had 4,000, you might think this is a massive reduction of excess weight on the roof. But be careful, because this value of 180 kilos is the excess ballast on top of these stones being placed. So everywhere you see a green square, this is one 15 kilo stone, and the weight of this 15 kilo stone is enough ballast for the specific modules that are nearby. If you see a red square with a value, this is the excess ballast which is needed on top of that. To get an overview of the total weight, you can find this in the report. And if we create one here, we will be able to see the difference between the ballast and the dead weight of the system on the roof. In our report, we can go to the results section for each roof. And we see, just by scrolling down, we see the amount of ballast that is needed. This is for our standard roof, 4,233 kilos, and the total dead weight that this occurs. So this is with then 12,800 kilos of excess material on top of the roof. Comparing this value to the case where we are using 15 kilo stones, we can see the stone option has 15,460 kilograms of excess weight on the roof. You'll also notice in this table there is different information as per the original table with the Mat S. This extra information is useful because it's telling you how many stones are being placed as replacements to the Mat S, in this case 440, and how much extra ballast would still be required on top of that as per the wind analysis for this project. In this case, it is 185 kilos, and this is made up of 16 stones at 15 kilos. The total number of stones, and therefore the total number of screws required for this project, will be 456. We can optimize this or play around with this in the base software by using different values for our ballast stone. And we can do a quick comparison by creating a third roof and using a separate, potentially smaller stone. In this case, let's do 5 kilos. Here you see the number of red squares have increased dramatically, and the amount of excess ballast has also increased. If we compare this with our overall ballast, though, this will be substantially less than the 15,000 kilos we saw in the previous roof. Looking at a little more details in the report, we can see that the total dead weight is 12,872 kilos. In comparison to the 15,000 ton, we have a value that is much closer to the minimum required ballast, which would be specified if we were using the Mat S. For this specific case, with 5 kilogram stones, we would need the 440 stones which replace the Mat S's. We would then need 410 extra stones to achieve the 2,034 kilos of extra ballast, which totals then the 12,800 kilos of dead weight. In this case, we would need 850 5-kilo stones. Another aspect of this design is that you can choose the height of the ballast stone depending on what is accessible. In this diagram, you see that the system can accept values between 50 and 250 millimeters, and this should be fine for the majority of stones that you can find around. It does also impact the amount of ballast, however, as the higher you take the rails and system off the roof, the more impact wind will have on the system and the more ballast you will need. We can see how this works by changing this from 100 to 200 millimeters. And you'll see now, even with the 15 kilo ballast stones that we had before, we need a lot more ballast placed around the roof. The range between 50 and 250 millimeters, which we saw before, is all part of the wind analysis and system analysis that we have done on our dome systems. And so as long as your stones are within this value, the statical analysis done on the system and the simulation is as accurate as it would be with our standard systems and the Mat S. Thanks for watching. Hope you've learned something useful and see you next time.